Hello everyone, welcome to WeLearn Tutorials. In this video we are going to do very interesting topic of class 10th, coordinate geometry. So this is chapter 7th of NCERT. So before starting the chapter, let us try to understand the meaning of coordinate geometry. So in coordinate geometry, we do geometry using algebra. So what is the meaning of that? See, geometry and algebra, these are the two branches of mathematics, and you are already familiar with this as you have done it in earlier classes. So geometry is that branch of mathematics which deals with the study of figures, lines or angles. And algebra is that branch of mathematics in which we do questions or we cover formulas or algebraic identities, you can say a plus b whole square, a minus b whole square, and the similar formulas. So this individually we have already done in earlier classes. So here we will do geometry using algebra, means we will deal with few figures like lines and square, rectangle. So like this you will be dealing with figures by using the formulas which are given to you in this chapter. So this you will understand better while you solve numerical problems. Now you are already familiar with the meaning of coordinate geometry. Let's understand, or let's be aware of where it is practically used. So it is used in navigation, engineering and physics. So if you are planning to continue maths or science in higher classes also, so that in that case you have to do this chapter very carefully. So in class 9th also you have done this chapter. So in this video I'll just give the introduction of few concepts, or we can say just recap the concepts which we have already done. So now let's start with the Cartesian plane. So here I have this type of arrangement. This horizontal line, this is x-axis, and this vertical line, this is y-axis. So this point you can name as x, this you can name as x dash, this you can name as y, and this as y dash. So this arrangement, it is known as Cartesian plane. So you will have two coordinates, x and y. You will have different values of x and different values of y. So here on this axis you will have values of x. Here also you have values of x. But this side you have positive values of x, this side you have negative values of x, and here it is 0. So this is the point where both of the axes, they are intersecting with each other. So this is known as origin, and it is represented by O. We can say this is origin, and mathematically or numerically if you say the value is 0 at this point, both x and y, they are 0. So like this you have to represent this point. Now this side or upward side of y axis, we can say it has positive values of y. This side it has negative values of y. Now I have already discussed together x and y, they are known as coordinates, and x-axis or value of x or point x, it is known as by the word abscissa, and y, it is known as ordinate. Now if you look at this setup, you can see here 4 partitions I have. So what are the names of these partitions? This one, it is first quadrant. Quadrants, these are known as, this one it is second quadrant, it is third quadrant, and this is fourth quadrant. Now coming to the values of x and y in all of these quadrants. If you see first quadrant, in first quadrant both x and y, they are positive. In second quadrant, from here itself you can see, in first quadrant you can see this axis is there and this one. So you can see from here I have written only positive values. So first quadrant it will have positive values of x and y. Now in second quadrant you can see, second quadrant it covers this axis for x and this for y. From here itself you can see x is negative and y is positive. So in second quadrant x is negative and y is positive. Let's see in third quadrant. Third quadrant you can see these values are there for both of x and y. If you see, you can see both x and y, they are negative. In fourth quadrant you can see x it is positive and y it is negative. From here you can see the values, x it is positive and y it is negative. So this was all about the Cartesian planes. Now in this chapter we have to deal with distance of any 2 points or distance of 1 point. So basically we have to find the distance. So now let's try to understand how we can find distance by using a Cartesian plane. I have taken a Cartesian plane. This is x-axis, this is y-axis. So only first quadrant I am taking as of now. First quadrant means x will also have positive values and y will also have positive values. So I will write the values. Horizontal line is x-axis and vertical line is y-axis. So this is origin. So first of all we learn how to find the distance of any point from x-axis. From x-axis means if I have this point here, I'll name it as point P. So I have to find its distance from x-axis. This is my x-axis, so this distance I have to find. This distance. So I will write here distance of any point from x-axis. So we'll see now how to find. So you have to, this is one line and you have to draw one dotted line also, horizontal line, because x-axis is also horizontal. So from this point we will draw horizontal line because we have to find distance from x-axis. So this distance, basically this distance, and these are parallel lines. Anywhere between two parallel lines its distance will remain same. So this line and this line, they are both parallel to each other, so the distance will remain same. So you have to join this point P on y-axis. So here just opposite to this point you have to see the value. You can see it is 2 on y-axis, which means this distance is, distance of this point from x-axis is 2 units. From where we got this 2? You can see we got this 2 on y-axis. So distance of any point from x-axis, you always have to remember it will be equals to y-axis. Y-axis means that point will be on y-axis. You have seen, I have shown you. We can take one more example. Let's take any point Q here and let's find its distance from x-axis. From x-axis means this distance you have to find, because this is your x-axis. So same way you have to draw one horizontal line parallel to x-axis, and this line you have to draw till y-axis. So now you can see opposite to this point you have to see or locate the point which is present on y-axis. You can see it is 4. So distance of these two, or distance of this point from x-axis, it will be 4 units. So that distance you will always find on y-axis. That's what I have written. Distance of any point from x-axis, it will be equals to y-axis. Now let's find the distance of any point from y-axis. So we'll take any point P. Let's assume we have taken this point, or here we'll take one point P. So now you have to find its distance from y-axis. So this is your y-axis, vertical line. So you can see this distance you have to find. So how you can do it? You have to draw a parallel line to y-axis and join this line on x-axis. See, or you have to extend the line from point P to x-axis. So you can see just opposite to point P you have to locate a point on x-axis. It is 4, which means this distance, but this means this distance you can see, because x is horizontal, and we can see this distance, it is 4 units. Same way you can take any other point also. Q you can take here. So you have to find this distance. See, distance from y-axis. So distance from y-axis means you have to draw a vertical line, and that line should join x-axis. Opposite to this point you have to locate a point on x-axis. You can see it is 6. So this distance, it is 6 units. You can see. So it will be 6 units, and you can, or you have observed that distance from y-axis you are getting a point on x-axis. So you can remember in this way also, whenever you are finding a distance from any axis, you can find that distance on opposite axis. If you are finding a distance from x-axis, you can get that value on y-axis, and if you are finding a distance of any point from y-axis, you can get that value on x-axis. I have shown you also. Now this was about the distance of any points from x or y-axis. Now let's try to find the distance of any point from origin. Origin is that point where both of the axes they are intersecting. So here I have one point P. So I have to find the distance of this point from origin. So from here I have to find the distance. So basically if this point is O, so I have to find OP. So what you have to do? Join this line. Vertical line you have to draw. This line is parallel to, vertical means it will be parallel to y-axis, and this line it will intersect, or it will touch x-axis. So now you can see vertical line means this will be a right angle triangle. So I can write this is triangle OP. So let's name this point as A, OPA, and this is, or OAP, we can better name it OAP, because this will be right angled at A. So we will find this distance OP or hypotenuse by using Pythagoras theorem. Why Pythagoras theorem? Because this is right angle triangle, and according to Pythagoras theorem we know hypotenuse square, it is equals to perpendicular square plus base square. Perpendicular means straight line on which 90-degree angle is there, and base this one. So hypotenuse you can write it is OP, which distance you have to find. P square is this distance, vertical line. So vertical line it will always be equals to y-axis. So y square you have to write because it is P square. So this is y, because this distance if you see according to this also, so distance of this point from here it will be equal to y-axis. Now OA, which is your base, distance of this point from y-axis. See, from this distance we have to see this one. So it will be equal to x square. From there also you can see distance of any point from y axis, it will be equals to x axis. So I have got OP square is equals to y square plus x square. So I'll just shift this square to other side, it will be changed to square root. So I will do rearrangement of this because this is addition only, so x square plus y square I will write. So OP will be equals to square root or root x square plus y square. So this is a distance of any point from origin. You can remember this formula also. And now let's find out the distance between any two points. See, until now we have only found the distance of one single point. Now let's find out the distance of 2 points from each other. So I'll explain it here. So let us assume I have 2 points. One point is A and other one is B. So I have to find this distance between point A and point B. So this is what we are going to use in exercise 7.1 also. So here one simple formula is given to you, the distance of AB, it is equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So here the coordinates of point A, it is given by x1 y1, and coordinates of point B, it is x2 y2. So this formula has been given to you. Directly you can apply this formula and find the solutions of exercise, but I will help you to find out how we got this formula. So we have to find the distance between point A and point B. See, distance formula I have already told you. If you want, you can directly start the exercise now by skipping this step. I just want you guys to understand how we derive this distance formula. So let's start now. Before starting, I just want to explain you few things on this plane. So here this is y axis, this is x axis. So I have been given 2 points, point A and B, whose distance I have to find. So here I have drawn this line BD and I have drawn this line, this is point A, AE. So these are the lines which I have drawn, and AC I have joined. So basically I have got one triangle ABC. This ABC triangle is again a right angled triangle because this is a vertical line. So vertical line means straight line, and one straight line it will always gives you a 90-degree angle. So this will be a right angle triangle. So basically what we will do, we will apply Pythagoras theorem here also. So this is hypotenuse, this is perpendicular, and this is base of the triangle. So let's apply there. So according to Pythagoras theorem, hypotenuse square, it is equals to perpendicular square plus base square. So we can write the values. Hypotenuse is AB, so I can write AB square, it is equals to perpendicular, which is BC square, plus now this is AC, base is AC square. From here you can see AC is base, BC is perpendicular, and AB is the hypotenuse of the triangle. Now we don't have the values of BC and AC, so let's find out the values of BC and AC first. So this point A is x1 y1 and the coordinates of point B is x2 y2. So if you see here, OE, it will be x1 because here the coordinate of x is x1. So if you see distance OD, here the coordinate of x is x2. So this distance, it will be OD, it will be equals to x2. And now I have drawn a line parallel PC, which is parallel to x-axis. Parallel means distance between parallel lines, it will always remain same. These lines are also parallel, vertical lines are also parallel, whichever lines I have drawn, and horizontal lines are also parallel, due to which PA, it will also be equal to this. You can see, because distance between parallel lines, it will remain same everywhere. If this is x1, this will also be x1. If this is x2, this will also be x2, due to which PC is equals to x2 and PA or AP will be equals to x1. Now we can see here, if you see this line, I can write this complete line is PC. I can write it as AP plus AC. See, two half lines I am just adding. This complete line is PC. If I add PA and AC, I will get PC. So that's what I have done here. So I need the value of AC. See here, AC I need. So AC I will write on this side and I will shift AP to other sides. PC minus AP, because AP is getting added this side, so on shifting the side, it will get subtracted from PC, is equals to AC. Now let's write down the values. PC, it is x2, and PA or AP, it is x1. So this you can write as PA also and AP also, it won't make any difference. So AC you got x2 minus x1. So in the same way, we'll now find the value of BC. If you see here, if I write this complete line BD, I just have to take BD. BD, it will be equals to BC plus CD. You can see one small portions I am adding and I will get the complete portion. So BC plus CD, it will be equals to BD. You can see I have properly named all the points also. And now if this is, see here, if you join these two, you can see this and these are parallel. So if this is y2, because here it's mentioned the coordinate of B is y2, so this will also be y2, because distance between parallel lines, it will always remain same. Now see here, this is, here coordinate of this point is y1, which means this distance is y1. If this is y1, this will also be y1. So I have written also. Now we need the value of BC. So BC I will write on this side and CD I will shift to other side. So BD minus CD. CD just I am shifting to this side, it's getting added this side, on shifting the side it will be changed into minus. Now we will just write the values. BD, see this complete line, it is equals to y2. CD. CD is y1. So BC is equals to y2 minus y1. So these two values I have got, and now I just have to substitute here. So AB square is equals to BC, I have got here y2 minus y1 is BC, and whole square we have to do. Same way AC you can see it is x2 minus x1. So I have just substituted the values of BC and AC. Now this square root I will shift to other side, so I will, this square, sorry, so this square I will shift to other side. On changing the side of the square or shifting to other side, it will be changed to square root. So y2 minus y1 whole square plus x2 minus x1. So this is the distance formula which I have already told you. So whenever you have to find distance between two points whose coordinates are given, see coordinates of these points are given to you, x1, y1, x2, y2, whose coordinates are given, you can directly use this formula and find the distance between these 2 points. So this is completely up to you. If you want to skip, you can skip also, because you just have to use this formula while doing the sums. Now in this video I will do this much only. This concept I will continue in the next video, in which we do exercise 7.1 of this chapter. So thank you so much for watching the video. Do like, do share.